is Dr. V. Anitha Rani, Associate Professor of Chemistry from Institute of Aeronautical Engineering. So we are going to discuss tutorial question bank, Module 4, Green Chemistry and Fuels. So part A, short answer questions. First one, what is green chemistry? So what is green chemistry means? It is the branch of chemistry which designs the chemical products and process that minimize the use and formation of or generation of hazardous substances, or we can write here that minimize the use or generation of hazardous substance is known as green chemistry. Nothing but we are going to eliminate hazardous substances by using green solvents. What is the importance of green chemistry? So green chemistry, by learning this concept, green chemistry, so we can avoid toxic substances. We can avoid toxic solvents, organic solvents. We can reduce here waste. We can use renewable materials. For example, we are using green solvents, ethanol and methanol that we can prepare from the plants. So renewable materials. So it plays a key role to develop green chemical methods to prevent the pollution in the environment. So when any time here, when we are preparing any chemical product, so if there is evolving of toxic substances taking place, hazardous substance, it will pollute the atmosphere. So that affecting what will be affected here in the environment? So health of the human beings, affecting of health of human beings, and affecting the plants and affecting the animals. So it is very important. What is the importance of green chemistry means? So mainly we can reduce the pollution in the environment. So next, what is green synthesis? So green synthesis means we will use the safer chemicals. We will use the green solvents in green synthesis. We can choose green solvents like water, methanol, and ethanol, acetonitrile. We can reduce waste and we can reduce hazardous substance. For example, we can take Novengel reactions where we can go for condensation reactions, condensation of carbonyl compounds with active methylene compounds in the presence of weak base. Means we are taking here basic condition, like we can use ammonia, amine or pyridine. So we can prepare the alpha beta unsaturated acids. So what is green synthesis? That is using green solvents in the preparation of chemical products. When we are synthesizing the chemical products. Example of aqueous phase method, already we know Novengel reactions, that example we can take. So here we are taking aldehydes and we are adding malonic acid and we are using the base, that is we are using in water based condition, where we can see a removal of carboxylic group CO2, removal of CO2 is taking place, and we are going to prepare alpha beta unsaturated acids. Alpha beta unsaturated acids. So this is an example of aqueous phase method. Example of aqueous phase method. So this is one of the green synthesis. So one of the green synthesis method, aqueous phase method. Example, Novengel condensation reaction. So next one, write about phase transfer catalyst. So phase transfer catalyst, here we use, okay. So in phase transfer catalyst, we will use phase transfer catalyst, we will use the catalyst. We will use the catalyst like phosphates. So where here this catalyst, it will transfer from one phase into another, from aqueous phase to organic phase, where chemical reaction will be taking place, and finally we get the chemical product. We get the chemical product. Next, what is ultrasound method? So ultrasound method means we can discuss here ultrasound method. So this will be worked based on the principle piezoelectric effect. So what is piezoelectric effect means? It is like equal and reversing charges are applied to opposite phases of the transducer, resulting generation of vibrations by expansion and contraction of the transducer, which emits ultrasonic waves. Very simple way. We will supply the electrical energy where vibration of the atoms will be taking place either by expansion, contraction of the transducer. What we are taking the material quartz, expansion, contraction of the atoms will be taking place. So when we are supplying electrical energy, it will be converted into here, that is sound, ultrasound, sound energy. So the term sonochemistry that is used to describe the effect of ultrasound waves on chemical reactivity. So this depends on phenomenon, that is sonic cavitations or acoustic cavitations. So here in example we can see, this is the example reverse effect we are following. We are applying voltage here, electric signal. We are applying electrical energy, converting into sound energy, sound vibration. So applying electric signal produces vibration or sound. So here we can take the example. Here in the diagram we can see where we are taking in a container transducer. When we apply electrical energy, converts into sound energy, where chemical reaction it takes place very fast. The rate of reaction will be very fast, where molecules or the atoms it will break very easily, and we get the final product. So you can see in the diagram. So we have kept on ultrasound generation that what we are taking ultrasonic water bath. We are taking a sample in the conical flask, and we are adding some solvent also, where you can observe here the bubbles are formed when we are heating that solution. When we are heating the solution, bubbles are formed. So here breaking of the bubble also will be taking place, bubble formation and successive propagation. So unstable size of the bubble. So after formation of the bubbles, then the bubbles will be breaking. So after breaking, a reaction will be taking place more, and we get the finally product. A product. So here we have given ultrasound method means we can write upon irradiation with the high intensity sound or ultrasound waves when we are passing to the solution, which are propagated a series of compressing refraction cycles pass through a liquid medium, what we are taking the reaction mixture. So oscillation of molecules taking place. So we will get like a vibration of the atoms, means that the reacting of molecules will be very fast here in this condition. So the attractive forces of the molecules may overcome, causing formation of bubbles, growth and collapse, which is due to great internal forces in the bubbles. So here completely we will get like bubbles we will get in the reaction mixture. So the bubbles will break, and immediately we get the product. So that is about ultrasound method. So next one, what is microwave method? Microwave method is nothing but we will apply heating. Means we are having in our homes microwaves. We will take reaction mixture in the conical flask. We will keep in the oven. So we'll keep reaction mixture taking in a conical flask. We'll keep in the oven. For example, benzylidine diacetate chemical we are taking in a conical flask. We are keeping in the microwave, and here we are adding neutral ammonia also in the benzylidine diacetate. We are preparing benzaldehyde. See, within a very short period of time, how much time it is taking here to prepare benzaldehyde is only 40 seconds. So by learning green synthesis methods, we can understand here 3 points. We will get high yield, like a 90% yield. Means here what happens? Reactants it will convert into products, chemical products. So 90% of the reactants will participate in the chemical reaction, and we get the products. So time consuming will be less time. You can see 40 seconds. And here temperature also we will take room temperature. So that is about microwave method. Next, write the applications of green synthesis. So applications of green synthesis, we can write So applications of green synthesis, we can write these are eco-friendly, where when we are designing the chemical products, we can reduce the air pollution. We can reduce the air pollution. So here, reducing the consumption of organic solvents, we can reduce the waste production, and we can reduce the organic solvents using green solvents. So the engineers provided chemical process here in such a way that we are preparing valuable products and materials, so there won't be any effect for the human beings. So that we have to write the applications. So next one, define fuel, give the characteristics of a good fuel. We all know now what is a fuel. So we'll write what is a fuel means we know. It is a combustible substance which on proper burning produces large amount of heat in presence of air. So fuel plus water gives rise to combustion products plus heat. So this we have to write what is a fuel. Give the characteristics of a good fuel. Characteristics of a good fuel means we have to write a good fuel should have low moisture content, low ash content. It should have high carbon content. It should have less moisture. It should have high calorific value. All these points we have to write. Next, write the significance of moisture and volatile matter in coal sample. So significance of moisture, if the percentage of moisture is more in coal sample, then reducing the calorific value, because if the moisture content is more present in the coal sample, when we are burning that coal, some amount of heat it will be evaporated in the form of latent heat of evaporation. So we should see that there should be always less percentage of moisture and better quality of coal. Volatile matter in coal, if volatile matter present in coal like CO, CO2, N2, so what happens means when we are burning that coal, we get a long flame, high smoke. Long flame, high smoke. So always a good quality of coal should have, low volatile matter. Compare solid and liquid fuels. Solid fuels, they are like here calorific value. When we compare calorific value of solid and liquid fuel, solid fuels will have less calorific value, liquid fuels will have high calorific value. Solid fuels will give more ash content, liquid fuels will give less ash content. Solid fuels combustion process will be, it does not take place complete combustion, incomplete combustion will be there. Liquid fuels, when compared to solid fuels, combustion process will be, here it will be fast, means complete combustion takes place in liquid fuels. So we have to write some differences between solid and liquid fuels. How is sulfur is determined by ultimate analysis of coal. So very simple here, sulfur how to determine by ultimate analysis means we have to add to the coal sample. Here what we will add means, to the coal sample we are going to add barium chloride, we will get barium sulfate. If sulfur is present in the coal, we get a barium sulfate precipitate, so that precipitate we will filter, wash it, dry it, and we will take the weight. So coal sample we have to treat with the barium chloride solution, we'll get a barium sulfate precipitate. So next, why gaseous fuels are more advantageous than solid fuels? Gaseous fuels, they have high calorific value than solid fuels, and gaseous fuels will mix with air very easily than solid fuels. Gaseous fuels will give less ash content compared to solid fuels. So these comparison, some points we can write. Why gaseous fuels are more advantageous than solid fuels. So main thing is gaseous fuels will have higher calorific value, more amount of heat will be liberated when we are burning the gaseous fuels compared to the solid fuels. Write the significance of fixed carbon and ash content in coal. Significance of fixed carbon. So if higher carbon percentage is there in coal sample, so we get high calorific value. ash content. If higher percentage of ash content in coal sample, we get low calorific value. So if there is a less ash content, then we get here calorific value, it does not decrease. What is CNG? Give the composition CNG. What is CNG means? It is a compressed natural gas. We'll prepare from natural gas, compressing the natural gas at 1000 atmospheric pressure at minus 160 degrees centigrade. Give the composition of CNG. What is present in CNG? 90% methane. 90% methane. 90% methane. Compare liquid fuels and gaseous fuels. So liquid fuels will have less calorific value compared to gaseous fuels. And next here liquid fuels, incomplete combustion will be taking place, and whereas gaseous fuels complete combustion will be taking place. So we have to write the difference. Liquid fuels will have less calorific value, gaseous fuels will have high calorific value. Liquid fuels will give here more CO, carbon monoxide residue, whereas gaseous fuels, it gives very less CO, least pollution. Next one, what is meant by calorific value of the fuel? Mention its units. Calorific value of the fuel means the quantity or amount of heat liberated when a unit mass or unit volume of the fuel is burnt completely in presence of fuel. That is called calorific value of the fuel. Units we have to write. So for solid fuels, we will write calorie per gram, kilocalorie per kilogram. For gaseous fuels, we'll write kilocalorie per cubic meter. So next here, what is LPG? Give composition and applications. So liquefied petroleum gas, it is prepared by refining of petroleum, and also here by taking a heavy oil, cracking of heavy oil, we can prepare LPG gas, and from natural gas also we can prepare LPG gas. Composition, here in composition we can write butane, N-butane, isobutane, you can write propane, composition of LPG. Applications means we will use in industries, different industries like a food industry or any other textile industry. We can use LPG, and we can use domestic purpose also liquefied petroleum gas for cooking. Next, write the classification of the fuels with suitable example. Classification. So classification of the fuels, there are solid fuels, liquid fuels and gaseous fuels. We have to write classification. Solid fuels, solid, liquid, gaseous fuels. So before writing this, we have to write natural fuels and artificial fuels. Artificial fuels. Classification of fuels, natural and artificial fuels. So this natural fuels will be again solid, liquid, gaseous. Artificial fuels also solid, liquid, gaseous fuels. So next one, compare gross calorific value and net calorific value of fuel. So gross calorific value and net calorific value. So here we will take here how much heat is produced from the fuel, heat when we are burning, and we are adding products heat. So here in NCV, low calorific value, so we will take only the net heat produced, and not included products heat. That we have to write. So next one, compare solid, liquid and gaseous fuels. Solid fuels, example coal, liquid fuels, petroleum, gaseous fuels, natural gas. Solid fuels, these for transportation, for storage, we can store easily, we can transport easily. but solid fuels will have low calorific value. Incomplete combustion will be taking place. More ash content we get. Liquid fuels we can go for means the transportation. It will be easy only. We can pass through the pipelines, and here combustion will be it will mix with air easily, and we will get pollution. But compared to solid and liquid, pollution will be less here by liquid fuels, and calorific value will get high calorific value compared to solid fuels. Gaseous fuels will get high calorific value, complete combustion, and it will mix with air easily, and will get here no pollution, less CO. So these points we have to write. So next one, what is part B questions, long answer questions. What is green synthesis? Explain about aqueous phase method. So what is green synthesis means? We are using green solvents in the preparation of chemical products. That we are designing the synthetic process in such a way that we are preparing the chemical products by using the green solvents, and we are following the methods that we will get a high yield, and we will prepare within a short period of time, and will take a temperature also room temperature. Explain about aqueous phase method. So we have to take here this only. We have to write this example only. Novengel condensation reaction. So next one, describe the phase transfer catalyst method with example. Okay, phase transfer catalyst method. Phase transfer catalyst method, what we do here is we will take here aqueous phase and organic phase. So two different phases we will use the catalyst, so here the catalyst, here the reactants it will move from aqueous phase. The reactants will move from aqueous phase into organic phase, and reaction takes place. So reaction occurs, and we get the products. So the reactants are moving from one phase into another, and chemical reaction takes place, and we get the products. So that we have to write in phase transfer catalyst method. So next, explain briefly about microwave method. So here already we have taken one example, that preparation of benzaldehyde by benzylidene diacetate. So that we have to write that we are taking on preparing this product like a benzaldehyde in 40 seconds. So that method we have to explain. Describe ultrasound method with a D diagram. So we are taking here ultrasound method example. We are taking here esterification. So here we are taking carboxylic group, and we are taking here this is a catalyst. We are using H2SO4 acid catalyst. We are getting a low yield and long time, but when we are going for ultrasound method, we are getting high yield, and we are getting we are preparing within a short period of time. So what we are going for, preparation of the esters. So by taking carboxylic group and hydroxyl group, so we will prepare the esters by ultrasound method. So that we have to write. Working principle also we have to write. So this one, piezoelectric effect principle. So next one, what are fuels? Give complete classification of fuels with a suitable example. So fuels, we know classification based on occurrence. There are natural fuels, artificial fuels. Natural fuels, so based on physical state of aggregation, solid, liquid and gaseous fuels. Here also artificial fuels, also solid, liquid and gaseous. So we have to write examples also for this. So like a coal, crude oil, and we can write natural gas. and here coke, petrol, and here you can write water, gas, etc. So next, explain the approximate analysis of coal. We are going to find out percentage of moisture, percentage of volatile matter, percentage of ash content, percentage of fixed carbon. So to find out percentage of moisture, we'll take coal sample. Coal sample we will take in oven and maintain temperature 110 degrees centigrade, and we'll find out the percentage of moisture. So you have to remember the formula. So here we are taking coal sample and we are taking in furnace, maintaining the temperature around 900 degrees centigrade. So for 7 minutes, and ash content we are taking coal in furnace, maintaining 700 degrees centigrade temperature for half an hour. And here fixed carbon will take percentage of 100 minus percentage of moisture plus volatile matter plus ash content. You can find out fixed carbon, percentage of fixed carbon. So we have to write here percentage of moisture, loss in weight by weight of coal taken into 100, percentage of volatile matter, loss in weight by weight of coal taken into 100, percentage of ash content, loss in or residue left, okay, weight of residue by weight of coal into 100. So this is volatile matter due to volatile matter. Okay, so this we have to write the formulas. Next, explain how the percentage of carbon, hydrogen, sulfur and oxygen is estimated by ultimate analysis of coal. So we can find out percentage of carbon. So we can write here that increase in weight of KOH bulk by weight of coal taken into 12 by 44 into 100. So percentage of hydrogen, increase in weight of calcium chloride tube by weight of coal taken into 2 by 18 into 100. So we have to remember the formulas, and we have to write how to find out percentage of carbon, hydrogen, sulfur and oxygen. So sulfur, percentage of sulfur, that is we can write weight of barium sulfate by weight of coal into 32 by 233 into 100. So percentage of oxygen is 100 minus percentage of carbon plus hydrogen plus sulfur plus nitrogen and ash. So nitrogen is very simple. Here weight we can write volume of acid used into normality of acid by weight of coal into 1.4. Volume of acid used into normality of acid by weight of coal taken into 1.4. So that we have to write here. Next, explain the refining of petroleum by giving its composition, boiling ranges and use of various fractions obtained during refining. So we have to write here refining of petroleum. Process we know already. We go for separation of the water, separation of sulfur compounds. Then we go for fractional distillation process where we pass through the long cylindrical tower, and we will arrange here. We can arrange the plates here. We will arrange the plates here. We will collect the petrol. We will collect the diesel. We will collect the kerosene. So we will collect all the fractions here. We go for refining of petroleum. So we have to write composition, boiling range, and here application also we have to write. So for example, composition of petrol is C5 to we can write C9. Boiling range like we can write 40 to 120. So we have to write for all the fractions its composition and boiling ranges. And uses also. Where we will use in internal combustion engine. Petrol we will use in internal combustion engines. So like that we have to write for various fractions, composition, boiling ranges and uses. Next, explain the composition properties and applications of LPG and CNG. So LPG composition we have to write that is isobutane, butane and propane, and properties we have to write, and applications we'll use for domestic purpose and industrial purpose. CNG also composition will be 90% methane, and properties here we can write it will mix with air easily and it gives very less CO, least pollution. Applications we will use in metropolitan cities. For in vehicles we will use CNG gas. Explain the ultimate analysis of coal, percentage of carbon, hydrogen, nitrogen, sulfur and oxygen. So we have to find out all these percentages, okay, in ultimate analysis of coal. So first we have to write the procedure. So next one, what is crude oil? Describe the refining of petroleum with various fractions obtained during refining and mention uses of each fraction. So what is crude oil means? It is like we are collecting from the under the sea. We are collecting the crude oil. It is like a brownish layer, brownish color oil we are collecting by the presence of the mixture of hydrocarbons. So it is formed by the decay of the plants and animals, and after a million years then we can collect the crude oil. A crude oil is formed. So distinguish, so we have to write refining of petroleum. So three process we will do: separation of water, then separation of sulfur, then separation of fractional distillation. So we have to write these 3 points here. So these 3 we have to write in refining of petroleum. So next one, distinguish the solid, liquid and gaseous fuels with its advantages and disadvantages. So we have to write what are the advantages and disadvantages. So solid fuels, for example, advantages means we can transport very easily, we can store very easily. But here solid fuels will give less calorific value. Liquid fuels we can transport. Here solid liquid fuels transportation will go through pipelines. But sometimes if leakage of the pipes will be taking place, we get the problems. And liquid fuels that sometimes incomplete combustion takes place by the liquid fuels, less calorific value we get. Gaseous fuels we can transport very easily, and here we get high calorific value and advantages. Here it will mix with very easily. Complete combustion of the fuel will be taking place. So that we have to write. So next, define the terms calorific value, higher calorific value and lower calorific value. Explain the relation between HCV and LCV. And here we have to write the difference between HCV and LCV, and we have to write what is calorific value, what is higher calorific value, what is lower calorific value. So we know here what is higher calorific value, what is lower calorific value. Higher calorific value means we will add products heat. We will take products heat plus net heat produced. Means we are cooling the combustion products. We are cooling combustion products. We are taking products heat and plus net heat produced. That is HCV. LCV means we are taking here, when we are burning the fuel, we are not including products heat. We are not including products heat. So only net heat we are taking. That is lower calorific value. We have to write the difference. CNG, LPG. The difference is CNG is we are preparing CNG gas from compressing the natural gas. LPG we are preparing from we are taking from refining of petroleum, and from natural gas also we are collecting higher hydrocarbons like butane, isobutane, and we are preparing from cracking of the heavy oil. So we have to write the properties of CNG and LPG. CNG gas, it is having high auto ignition temperature, compared to the LPG. And the CNG gas we are using in metropolitan cities. This is giving very less CO and least pollution compared to the LPG. So next, explain how the percentage of moisture, volatile matter, ash content and fixed carbon by proximate analysis of coal. So that already we discussed. Here we have to find out percentage of moisture, volatile matter, ash content and fixed carbon. So that is 100 minus percentage of moisture plus volatile matter plus ash content. So we'll get fixed carbon. So that we have to write in proximate analysis. So next one, define natural fuel and artificial fuel. Write the characteristics of a good fuel. So here natural fuel that we are collecting or obtaining from nature like a coal, petroleum, natural gas. Artificial fuel, that is we are preparing artificial fuels from natural fuels. Okay, we are preparing a secondary fuels from natural fuel. Nothing but we are taking a crude oil and from the crude oil we are collecting the diesel, petrol, kerosene. So that is artificial fuel. So characteristics of a good fuel. A good fuel should have low ash content, low moisture content, and here it should give high calorific value. It should have moderate ignition temperature. So that points we have to write. Next, explain the significance of proximate and ultimate analysis. So what is the importance of proximate analysis, ultimate analysis? So by proximate analysis, we can find out that there should be less moisture, less volatile matter, less ash content in coal sample, then good quality of coal, or the good quality of coal. Ultimate analysis, we are going to find out percentage of all elements, carbon, hydrogen, nitrogen, sulfur and oxygen, so that we will know in a given coal sample how much carbon content and hydrogen percentage, how much it is present in the coal sample. So by knowing the percentage of carbon and hydrogen, we can easily know whether it can give high calorific value or low calorific value. Next, explain about composition properties and applications of compressed natural gas. Composition means 90% methane will be present in compressed natural gas. Next, properties, that is it is colorless and odorless. It should be colorless and odorless. And to detect the leakage of the gas, we will add sulfur based compounds. It will mix with the air easily. It will give very less CO and least pollution. It will have high auto ignition temperature compared to the other fuels. So that we have to write. Applications means we will use in vehicles compressed natural gas. Explain the significance of analysis of coal. Here we have to write both proximate analysis and ultimate analysis. Next, explain about composition, properties and applications of liquefied petroleum gas. So we have to write the composition of LPG, properties and applications. Then part C, problem solving and critical thinking questions. What is the importance of green chemistry? So nothing but here we are going to reduce or eliminate the hazardous substances by using green solvents. And we, first of all, what is the here importance means we are going to reduce the pollution in the environment. Explain about the phase transfer catalyst method with example. So phase transfer catalyst method, nothing but we are going to use the catalyst where a reactant will transfer from one phase into another and a chemical reaction takes place, we'll get the product. Next, what is meant by green synthesis? Explain any one method to eliminate or minimize hazardous substance. What is green synthesis means? We are going to use green solvents in synthetic means in chemical products when we are preparing chemical products. One method means we can explain any one method out of the 4 methods. We can select one method and we can write. List the various steps involved in refining of petroleum. 3 steps are there. Separation of water, separation of sulfur compounds, fractional distillation of petroleum. At what temperature kerosene, diesel and gasoline are obtained? Only 3 fractions here. We have to write the temperature, at which temperature kerosene is obtained, and at which temperature diesel and at which temperature petrol is obtained. We have to write the temperatures and how do they differ in their composition. In their composition, what is the composition of kerosene, diesel and gasoline? So we have to write. For example, petrol composition is C5 to C9, C5 to C9. Whereas diesel we can write, here we can write C10 to C18. Here kerosene we write C10 to C16. So different composition is there, so that we have to write for kerosene, diesel and gasoline, and different temperature also we have to write. So next one, why a good fuel should possess low oxygen and high carbon percentage? If good fuel, it should have always low oxygen content. If high oxygen content is there, it will be in the form of moisture and decrease in the calorific value, and increase in 1% of oxygen, 1% of oxygen, decreasing 1.7% of calorific value. So that we have to write high carbon percentage. So carbon is the main combustible substance in the fuel. If the fuel is having high carbon percentage, then we get more calorific value. So that we have to write here. Next, why is net calorific value less than gross calorific value? So in gross calorific value, we are taking the product's heat. We are cooling the combustion products. How much heat is liberated? So that heat we are including in the net heat produced when we are burning the fuel. So we are taking product's heat and net heat in gross calorific value. Net calorific value, we are not cooling the products here, combustion products. We are allowing, means we are escaping outside. We are taking only net heat produced. That is the, here we have to reason, we have to write here, why is net calorific value is less than gross calorific value. Net calorific value is less because we are not including combustion products heat. So that we have to write. Next, calculate the gross and net calorific values of coal sample. So here we are giving some problems to find out gross calorific value and net calorific value. So we can know the percentages: carbon percentage, hydrogen percentage, and sulfur, oxygen, nitrogen and ash. And we can find out here. So here we will take, we have to remember two formulas here. So we have to remember two formulas in the problems, HCV formula and LCV formula. Then we apply the percentage of carbon, hydrogen, oxygen, sulfur. We will multiply and we will calculate and we will get the answer. Okay. So like that we have to do the problems. HCV is equal to 1 by 100 into 8080 into C, that is carbon, plus 34,500 into H minus O by 8 plus 2240 into sulfur calories per gram. So this is the HCV formula. LCV is equal to HCV minus 9 into H by 100 into 587. So we have to apply the values in the formula, then we can find out LCV. So all the problems we have to do, so by applying these HCV and LCV formula, or it is also called GCV and NCV, gross calorific value and net calorific value. So we got the problems here 1, 2, 3, 4. For 4 problems, we have to apply here formulas. We have to apply the formulas. We have to find out the here calorific value, gross calorific value and net calorific value. So we have to learn here formulas. Then we can find out net calorific value and gross calorific value. So here 4th problem also we got here percentages for all elements like carbon, sulfur, hydrogen, nitrogen and oxygen. Carbon 75%, sulfur 1.2, hydrogen 5.2, nitrogen 3.7, oxygen 12.8. Here, okay. So these problems no need. So we are discussing up to gross calorific value and net calorific value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.